the Eris webinar, The Future of Cellular Connectivity for Fleet. I'm Jack McCarthy with Eris, and I'll be introducing the presenters for today's exciting webinar. Syed Hosain, Eris CTO, and John Bean, Eris Business Development Executive. During the webinar, you'll be able to ask questions by writing in the question box, and the speakers will answer them at the presentation's conclusion. Following the webinar, we will send you an email with a copy of slides and a recording of the event. So let's get started. Z?
Thank you, Jack. I'm going to be talking about fleet management and what are the characteristics of the fleet applications and some of the technology issues and things you might want to be aware of that are taking place for fleet management applications, the technology changes in the future. So let me get started first by talking a little bit about Eris, who we are. I'll have a few slides on the company and then get right into the presentation material. We are a M2M and IoT pioneer. We've been in existence for more than 19 years, providing services since the mid-1990s for a variety of different applications, including fleet, obviously. We provide a solution that has been a fairly, the best way I would say it is that it is a fairly optimized M2M IoT platform designed for these kinds of applications, where we provide a complete solution from end to end, from connectivity all the way to application enablement. And recently, we also deployed a new capability called NEO, which allows people to get operational with rapid M2M deployment very, very quickly. Within 24 hours, if they already have a device, they can get SIMs and proceed. Our customers are typically enterprises, small, medium, and large companies who are deploying M2M and IoT applications. And they are using our systems for a variety of purposes, ranging from connectivity to and from devices, all the way to analytics, content analysis, analytics that can lead to making business decisions, which is why you would want to deploy the M2M or IoT application in the first place. From a numbers perspective, we have a very reliable infrastructure for machine applications, and that's very important because machines are not as smart as human beings can be and compensate for cellular problems that might occur out in the field. So we have to make sure that we provide good, reliable infrastructure, good, reliable service. We're currently deployed in 190 plus countries, third in the US in terms of the number of M2M devices that are deployed, 9th globally, certainly in the top 10, 9th globally, and supporting about 250 million messages, M2M messages per day. On the next slide, we talk about the markets that we provide these services for. Basically, there are 6 categories: healthcare, telematics, which is the area that fleet management falls into, consumer auto, monitoring and control, point of sale, utilities. And what we provide is a complete solution. In the middle box, you see a complete solution, the M2M platform that we provide. From the bottom upwards, data and voice connectivity for the devices that are in the field, device and IP session control, and then all the way into provisioning, real-time information, alerts and alarms for the devices that might be transmitting a particular alert that needs to be responded to as a business action, billing and reporting, of course, and we provide account-level NOC support for the devices that are out in the field. And at the top, you see the connectivity enablement, which is our airport portal. I'll have more information about that in a moment, and application enablement for content analysis. And we provide this on the cellular networks, basically globally, worldwide, over a large number of carriers, more than 500 carriers in our network, depending on the countries that you want to operate in. And here's the important point. We do this for 2G and 3G, CDMA, and GSM, as well as our 4G LTE platform that is being rolled out as we speak. The CDMA and GSM is actually kind of unique to us. Depending on the customer's needs, you might have a CDMA product or a GSM product, or maybe even a hybrid. In some countries, you might operate CDMA, like in the US, and in European markets, you might take GSM. There are many radio suppliers who are providing plug-compatible similar radios in each technology that could be swapped out for a new design, which is operated in a different country, for example. Our technology stack, this is our M2M platform. At the bottom, you see our AirConnect services. This is the actual cellular connectivity services that feeds the data into our own core network. A very important point and distinguishing feature about Eris is our AirCore system, which provides optimized M2M solutions from a core network perspective, very different from the cellular carriers that are out in the field that are deploying M2M applications as well. Then we have connectivity enablement, which is airport, and application enablement, which is Air Cloud. The connectivity enablement is where you manage the devices, you troubleshoot and control the costs associated with the transport. And Air Cloud is where you rapidly develop and deploy the M2M applications from a content analysis perspective. On the right-hand side is the back office systems that provide all the billing and operational support for these applications, the flexible business models that we provide, and the operational requirements that a customer might have for operating their application on our network. At the top are the applications. Now, I just show 3 applications there. Those applications are the ones that the customers would typically deploy out in the field, although Air Cloud could enable them if necessary. Now let's get into fleets themselves. I classify fleets into 3 categories for the purposes of the rest of this discussion. First, they are the regional short-haul fleets. These are typically vehicles that are being used for local deliveries. Maybe they're field technicians or taxi cabs, etc. Generally speaking, these are a smaller number of trucks and vehicles per customer. You might have a customer who's got a 10-fleet flower delivery operation, or maybe 150 fleets in a field technician office, localized office that only sends those vehicles in local regions. The second category is the national long-haul fleets, where you have companies that are sending cargo in trailers, typically across the country, or maybe even traversing from Canada all the way into Mexico. These long-haul companies generally have a larger number of vehicles per customer, and they're generally moving around in more than one area. So it isn't just a regional operation. They might be encountering multiple carriers, multiple highways where they would need to get service. And then, of course, the third category is the rest of the kind of fleets that have vehicles that may need monitoring for M2M applications, such as automotive fleets, rental cars, corporate vehicles, etc. Now, I don't consider consumer automotive telematics functions, such as might be enabled in your car, in your personal vehicle, to be part of this category over here. This is really larger fleets that are being used for commercial purposes in general. And of course, heavy equipment, such as construction equipment or farm combine equipment, road building equipment, etc., that is being used out in the field and needs to be tracked either from a usage perspective or theft recovery, or just generally having these M2M IoT applications that allow them to get value on their assets. There are common needs for all of these fleets, whether it's a regional, national, or other fleets. First and most obvious is the location. Clearly, I'm borrowing from the real estate market here, location, location, location. It's important for the device to know where it is. That asset location is very fundamental. This is a sort of an obvious statement that I'm making here, but you need to know where your asset is. You need to know where your vehicle is for most of the applications that the M2M devices are being used for. These devices often use a GPS for accuracy, even in metropolitan areas where you could get triangulation information through other mechanisms, through network mechanisms. Generally speaking, GPS is low enough from a cost perspective that it is natural to employ using GPS as part of your devices that are out in the field. Most cellular radios that are being used for M2M applications have built-in GPS technology anyway. Obviously, this is a bidirectional data transport. As opposed to recording information from a sensor, you will have both information being transmitted from and to the vehicle. Typically, you'll have location, events, data logs, driver logs, other kind of data being transmitted from the vehicle. And you may have information going back to the vehicle, the driver, such as a dispatch information, or a new route to follow, or maybe a cargo bill that needs to be signed somewhere, etc. Their bidirectional is very important to this aspect of the market for fleet management here. Another important requirement is the devices have to be hardened. In other words, you have to deal with temperature issues, vibration issues, more complicated installations that are required by these applications simply because they are going to be in a moving vehicle. And they have to be integrated in general more effectively with the vehicle, such as the sensors or maybe the vehicle networks, or if you have an application that requires battery management to be able to turn off the unit when the vehicle is not being used, etc. You need to integrate it very carefully into the car in question or the truck in question, etc. So what are the characteristics of these 3 categories of fleets? First is regional fleets. I'm just going to give you a few examples. Typically, there's a lot of dispatch requirements. Unlike the national fleets where a dispatch might occur once in the morning, in the regional fleet, you might be able to might need to contact the vehicles more often, maybe to add a new stop along the way, or change a route. And the sessions generally tend to have more starts and stops involved. The vehicles are not moving for long distances, or maybe moving from one location to the other where they have to be turned off and turned back on again. So you'll have more transmissions to deal with. In general, they are located in markets where cellular data services work pretty well. And so cellular is the most common platform, most common transport mechanism used for these fleets. From a national fleet perspective, you might have more regulations that you have to deal with. A regional fleet would not necessarily worry about tire pressure, but a long-haul truck has to deal with tire pressure measurements just about every morning from a regulations perspective. Driver logs have to be kept, and vehicle driver history has to be recorded. All of that information is very critical. They also have a time-sensitive issue. In the morning, typically, most dispatches and logs will be sent to the vehicles, and they have to arrive in time so the drivers can indeed drive to where the locations need to be, and they need to get dispatch information on a time-sensitive way. Coverage is an interesting issue, slightly different than regional fleets because they tend to be on highways. And just about every highway is covered very well with cellular, but if you happen to be off the beaten path into a secondary or even a smaller highway than that, you might have a coverage hole that you need to understand. The information in the morning, the regulation information perhaps being sent for tire pressure logs is not an issue, but dispatch might need to worry about coverage holes later on. The other fleets typically tend to be asset tracking. They're tracking a vehicle and an individual, not necessarily content. In the national fleet, you might be tracking the content of a trailer or a cargo, but in a auto rental fleet, you won't be worrying about who's in the car. You'll be more worrying about the location, etc. These tend to be event-based applications. Maybe a car crash has to be transmitted, or theft, or maybe a route download has to be sent to a rental car, etc. If the car has been stolen, if the vehicle's been stolen, you might need to be able to do remote engine stops, etc. The network for these devices is usually cellular, more often than not for the vehicle fleet. But for heavy machinery, particularly in remote locations, you might have a satellite or a hybrid device of some sort. In a very remote location in where the vehicle is being sent to an oil rig in the middle of nowhere, perhaps, you might need to worry about having a satellite backup if that's critical to the application that is being used for that particular end-to-end device. So what's the technology that's being used today? In a regional fleet, most people are using either 2G CDMA or 2G GSM GPRS devices. Why is that? Because the coverage in metropolitan areas is excellent from both of these technologies, and the transmission requirements for most of these applications isn't high enough to warrant using anything other than 2G. In a national fleet, most are using CDMA, not GSM, partly because at the time most of these applications became commonplace, began to be deployed. The coverage footprint from the CDMA side was much better nationally, nationwide on the highways, etc., than GSM. And so they began using 2G CDMA and they've continued using 2G CDMA. In the case of the other fleets, the technology depends on the coverage requirements. It's generally within the major metropolitan cities, it tends to be 2G GSM for the regional, the small fleet applications. But in terms of U.S. telematics, now I mentioned a consumer application in this particular case, they tended to use 2G CDMA primarily because the vehicles were pretty much sold anywhere in the country. And so the U.S. essentially, the 2G CDMA essentially dominated the deployment of those vehicles. So rental fleets tended to use CDMA as well. But 2G GSM was very common for many localized applications, and that was a technology in use. Now, where's the technology heading? What are the futures that are being deployed here, if you will? Regional fleets are typically moving to a 3G HSPA or even a 4G LTE solution, but 4G today, the module price is an issue, and I'll discuss that a little bit more in a moment. Generally speaking, the coverage in metropolitan areas is good to excellent. 3G HSPA is available just about in every large and middle-sized town in the country. 4G LTE, getting there, definitely in a stage where at some point when people start using 4G LTE radios, the coverage will probably be good enough or will be better than necessary for these kinds of fleets. In the case of the national fleets, they tend to be on the highways and rural areas much more so than a regional fleet would be for obvious reasons. And therefore, they're trying to wait for the 4G LTE coverage to improve. They also have a little bit more of a, I will call it a timeline runway, since they are 2G CDMA, and given the fact that 2G CDMA is operational in those markets for a lot longer than 2G GSM, they can afford to wait for a 4G LTE solution where the need to go to a 3G solution for HSPA, for example, in a metro area is much more critical for a regional fleet. In the case of the other fleets, the metro deployments, the regional applications, are also moving to 3G HSPA because they tended to be 2G GSM today. And they're moving to 4G LTE only if the module price and the device availability justifies it. The rural applications, such as the combines and farm equipment, are also waiting for 4G LTE if they are not using 2G GSM today, because there's a timeline issue, a sunset issue that you need to deal with. So what are the change drivers for the technology? What is affecting the selection here? First of all, there is as some of you will be aware of this, the 2G GSM sunset that is occurring in the United States. By January 2017, a migration from those applications to a 3G HSPA or 4G LTE is required. Luckily, the 2G CDMA folks have more time to wait. So if you look at it from the perspective of a metro application that's using 2G GSM, they have to move within the next couple of years. If you have a 2G CDMA application, perhaps in a fleet application, you have some time. You can wait. Now, the other important point is that when you deploy a technology, a multi-technology device, or maybe a cross-technology device, where you have to fall back from a 4G LTE solution to a 3G or 2G solution, that can get pretty complicated. It's another reason why the long-haul fleets are waiting a little bit, because they'd rather use LTE exclusively when it's available in their markets rather than having to fall back to 3G or 2G. You have to manage that in the device, in the network, etc. Now, in the case of a fallback from LTE to EVDO or CDMA, which are not inherently the kind of technologies that the ITU deployed for fallback from LTE to HSPA, for example, that tends to drive a little bit more complexity, and therefore the people who are doing 2G CDMA long-haul trucks, for example, are waiting a little bit to deploy 4G LTE when it becomes available. And the final issue I mentioned a little earlier is that the 4G LTE module prices are still pretty high. Generally speaking, anywhere between 3 to 5 times more expensive than a CDMA radio, and maybe even 7 to 10 times more expensive than a GSM GPRS radio. But the prices are dropping steadily, faster than these earlier technologies ever did. And at some point, you will start to see LTE-only modules happen. That release is going to occur in the next year and a half to 2 years, and then fully deployed, if you will, fully available, if you will, by 2018. The devices that use those LTE-only modules, and that I think will precipitate a rapid change into the LTE market for these fleet applications. So, some final thoughts. Deploying a fleet application, there are absolutely clear gains from that. The ROI is clear. It's easy to calculate those requirements. The efficiency gains and the cost reductions you get are very commonly understood. Most people who are deploying these applications truly get a clear win for having done that when they put these applications out in the field. Another important point is that the regulations from the federal and state governments are increasing, particularly for national and long-haul trucking, where the requirements for doing logging and driver monitoring are increasing to the point where if you don't take advantage of some of the M2M and IoT applications to do the automation of the functions that are being required, it's going to cause some efficiency losses. And so these new applications are being developed, they're being deployed, etc. Today, cellular dominates, and I think cellular will continue to dominate because the cellular services truly cover the vast majority of fleet locations. If you truly have a remote site where you need a satellite or a hybrid solution, that's where you might put one in if the truck is, or the vehicle, or whatever the fleet is going into locations where cellular is not available and the transmission requirements, the immediacy of transmission requirements is paramount. I would say the large majority, the vast majority of devices and fleet applications, cellular is completely sufficient. So that's pretty much my presentation, Jack. I'll hand it back to you.
Thank you, Z. Now I'd like to turn it over to John Bean, who's going to demonstrate some of the features that Eris offers. John?
Yeah, thank you, Jack, and thank you, Z. As Z mentioned, Eris is a leading provider of fleet connectivity to fleet solution providers. It has been for over 10 years. And when I speak to our customers, our fleet customers, they select Eris because we deliver a higher quality of service, better coverage, and are able to offer them a lower total cost of ownership than traditional fleet carriers. One of the ways we do that specifically is with our supply chain optimization and the ability to create and tailor our rate plans to fit whatever needs and requirements that they have. So what I wanted to start off with before I get into the actual airport demonstration was just to go through one slide that kind of depicts the life cycle of a SIM or a device on the Eris network. One of the unique things that Eris is able to offer as a carrier is we give the ability for our customers to provision and activate devices, at their manufacturing facilities, whether they're offshore in Mexico, Asia, or before they ship devices to customers. So they're actually able to activate SIMs, provision CDMA devices on the Eris network, and test those devices without incurring any fees, any usage charges, or anything like that for up to 12 months. This allows our customers to actually ship devices in a provisioned state, and only when they start generating revenue for our customers, when they're installed, in vehicles, in fleets, generating data, exceeding whatever usage triggers that we usually include, that's when they transition from a non-billable to a billable state. This is one of the ways that we lower the operational costs for our customers. We also have a lot of fleet customers included that are somewhat seasonal in nature, whether it's school buses that aren't operating in the summer, maybe snow plows that aren't working in the summers as well. And so we give our customers the ability to suspend the devices when they're not in use, or if a device is taken out of the field, and avoid having to pay any monthly usage fees or data fees associated with the device. Then we allow them to actually redeploy the device. There can be a trigger associated with it. When that's succeeded, it'll come out of suspend back into a billable state. Then typically our fleet customers, they sell their solutions with 2-3-year contracts. If those agreements are not renewed, perhaps if they're canceled, we allow our customers to actually reprovision the devices, preserve the phone numbers, the MDMs if they're CDMA devices, and start this process all over again. So one of the unique differences is that we're able to give our customers an allowance of test data, test the devices, ship them live, for up to 12 months, and that's one of the bigger differences that Eris is able to offer customers as a carrier. So I just wanted to cover that, and then I'm going to jump into give you an overview of the airport connectivity platform, and because we're a carrier, we're able to offer a lot more, visibility and control over the behavior of devices on our network. We're able to see in real time traffic, usage, alerts, and things like that, which leads to quicker resolution of trouble tickets, better diagnostics. The alerts that are generated are in real time, and we also have traffic policies that can block traffic, prevent any risk or exposure to any unplanned usage or overage. So I've already logged into Airport, and Airport's organized, kind of in a tab format across the top. There are various sections. This is the dashboard. We've got a provisioning tab, devices tab, support, and tab. I'm going to go back and start on the dashboard. The dashboard is where it gives you a 30,000-foot view of your environment, any devices that might need attention, any devices that have exceeded any alerts or thresholds, and I can drill down and look at some of the devices, and then more importantly, I can select the device I might want to look at. And this is really kind of the secret sauce in Airport, is having this deep visibility into a device. We're able to do more, diagnostics and troubleshooting. I can see if a device is connected on our network. I can see that it's been provisioned. I can see that the time it last registered if I hover right here. It's not currently in a packet session. But if it was in a packet session, I wanted to troubleshoot the device, I can actually come over, I can clear the registration of a device, I can ping a device, I can send a device SMS type commands, and even get convert it to a voice capability and get a local dialable number. I can also see the last 100 transactions for that device, which helps me to determine that there's maybe not an issue with the device or the tower, or a coverage issue. But this in itself, provides a lot of visibility, allows us to, resolve issues quicker, prevents truck rolls. It's one of the major differentiating features of Aeris. I also want to mention that everything that I'm going to show you today can be accomplished with our APIs. We have a full suite of APIs that customers use to provision, report, activate devices, and things like that. I'm going to go over to the provision tab, and another way we allow customers to gain a competitive advantage, with Airport is by providing them with the ability to support multiple technologies. I can provision both CDMA and GSM devices. I can do bulk provisions up to 10,000 devices at once. And as I previously mentioned in the first slide that I showed, when I provision a device, I'm actually activating it on the Eris network. It's being assigned a phone number. It's active. It's just not billable. It's not going to go into a billable state until we surpass one of those thresholds or triggers, and those triggers can be based on data, voice, SMS. And we can also, if I wanted to, I could start a device and provision it and have it go right into a billable state. One of the other unique capabilities in Airport is the report group. And what the report group allows me to do is it allows me to assign specific devices to a report group, which actually, when I go into the billing in the report, it allows me to sort and filter devices by report group. And a report group can be a customer, it can be a reseller, distributor. And then when we're looking at our detailed or summary reports, I can actually total and look at my cost on a device basis or by a customer basis or by a report group. We also provide custom fields if you want to track devices, where they're located, firmware versions, device hardware versions, and things like that. And we also give you some custom fields. The devices is we can display and filter this a number of different ways. I can perform bulk operations if I want to cancel, suspend, block traffic, and things like that in the Devices tab. The Support tab gives me an overview of all the devices on my network. And like, for example, in the device summary, I can actually see how many devices have been provisioned there. They're reflected in this green bar. I've got, in this example, 402 devices provisioned, but only 308 that are actually billable. And as more of the devices that I've employed, that I've installed or shipped to customers come online, start transmitting data, they're going to transition from this provision state to a billable state. And so it gives me kind of a snapshot of how many devices might be in the field, how many are provisioned versus billable. We also include a variety of different reports. Some of the most useful reports are the summary reports, which provide you on a row-by-row level every device. It shows you a total cost for every device, including SMS, voice, data, text, any fees associated with the device. We get down to the summary level. We can also provide detailed reports that show you every transaction associated with the device. We also have a fully functional trouble ticketing system, allow you to submit tickets, troubleshoot devices. I'm not going to go into that. But under the administrative tab is where we actually give the capability to create alerts and thresholds. And because we're a carrier, we're actually seeing all the data through our network in real time. The alerts that you create, whether they're based on daily or month-to-date or hourly voice data, SMS, they're actually triggered in real time, posted to the dashboard, and then actually email notifications are also sent out. It's real simple to create a new alert. We simply give it a name, a description. I can give it a time period. I mentioned I can have hourly, monthly, or daily alerts. One of the newest features that we implemented last year was the ability to actually create traffic policies. And for a fleet customer, traffic policies are very, very important because in order to control your risk and exposure to any overage, unintended usage or different service plans that you might offer your customers, we can actually limit the amount of data on a monthly basis. For example, if you have a fleet customer that reports every 5 minutes, maybe uses a half mega data per month, we can actually set an alert to trigger at 1 meg of usage per month. And then for a safety precaution, maybe at 1.5 meg, I can actually have a traffic policy that's automatically implemented, takes corrective action, and blocks all data or packet data, voice to that device at 1.5 meg. So one of the hardest discussions to have with customers are discussions involving overage, unintended usage due to rogue devices, maybe spamming and things like that. We don't really have any of those issues. Our network's a private network. Our phone numbers are all unpublished numbers, and we also have the ability to create these traffic policies that can kick in real time and prevent any unintended usage and exposure to overage. So that's one of the unique features that a lot of our customers have been implementing, and that I wanted to point out. If I go back dashboard, this is where I can actually see all these different alerts. This is a test account, by the way, that have triggered. And if I want to, scroll down, and I can see on this specific alert for registration alerts on a daily basis, I've had 6 devices that have triggered. This is where I would drill down and actually look at those devices, maybe report on them, or take a look at them if I want to select this device in the dashboard and troubleshoot it a little bit. If there was an issue and I wanted to contact Eris support, I could simply create a support ticket. All the contents from that device, would be copied into the ticket. Saving a lot of time as far as operational troubleshooting and things like that. Thing that I wanted to mention is all of the users of Airport or assigned logins are all based on different roles. We have different roles for different types of users, for billing, provisioning, and things like that. So that's kind of a quick, overview of Airport. If everything that I do in Airport, again, I can do and implement with APIs. A lot of customers have extended the logic into their back office type systems using the API. So with that, I'd like to pass it back over control to Jack, and we can now take time for any questions or answers that anyone else might have in the audience.
Thanks, John. We have a few questions here we'd like to get to. Z, here's one for you. We have 2G right now with AT&T and are thinking about trying to get ahead of the curve and transition to LTE right away. What are the pros and cons of doing that?
That's a good question, Jack. Let me address it in the following way. It depends. The answer, unfortunately, is going to be one of it depends. If your 2G GSM application you're using on AT&T right now has a price sensitivity or you need to worry about adding in an LTE solution at this point that might be a little bit too early for you, then the transition, there's a variety of possibilities. You can deploy a 2G CDMA application in many markets that continue to work quite well beyond the 2G sunset dates announced by AT&T. It will be available in most of the rural markets for at least 6 to 8 more years, and that is an advantage that is a price advantage that allows people to make that transition relatively painlessly. Going to a 4G solution right away might be a little bit too expensive. So that would be something that I might recommend only if the cost is sustainable. Now, there are also 3G HSPA possibilities, and in many markets, if it's a regional application, that might be fine. If it is more of a long-haul application or a rural application, I'd be concerned. I wouldn't go to a 3G HSPA solution. I'd consider 2G CDMA instead, because the coverage of 3G HSPA isn't as good as 2G CDMA today, and it's not likely to change much because the carriers are focused on deploying 4G LTE rather than 3G HSPA in markets outside the major metropolitan areas. So the pros and cons of going to 4G or LTE is really simple. Can you sustain the cost today, or will you have coverage available later on? If, however, you want to have a long-term solution that for the next 5, 10, 15 years you're going to want to sustain, then 4G LTE might in fact be the right option for you. So the transition plan, in summary, from that long-winded answer, 2G GSM, you could go to 2G CDMA, or you could go to 3G HSPA, or consider 4G LTE if you can handle the cost issues.
Thanks, V. John, here's one for you. What are some of the benefits of the alerting system in airports?
Great question. The main difference with our alerts is since Eris owns and operates the underlying core network, our alerts are actually generated in near real time. The latency is 3 to 5 minutes at most. And with our real-time alerts, you're able to, as I mentioned earlier, control any risk you might have to any unintended usage or exposure. And you can combine alerts with our traffic policy to actually prevent any further usage while you, investigate, use our dashboard to dive deeper into that device to see why it might be consuming a lot of data, SMS or voice.
Okay. Z, most of the information I read about cellular is for long-haul fleets, but my company delivers regionally, and we have lots of cellular drop zones. What's the story with coverage? Can any provider reliably service rural areas?
Well, that's a two-part question. So let me talk about both the regional aspect of it, and the rural area aspect of it. First of all, cellular is used for long-haul fleets simply because when you're out in the middle of nowhere, that's about the only wireless transmission technology you're going to find is cost-effective. You could, in theory, use satellite, but it's highly unlikely that that's the performance you would need for the kinds of data transmissions that typical application might have. So for a long-haul fleet, obviously cellular is the right thing to do. Now, if you're doing regional deployments and you have drop zones, cellular dead zones, it depends on what's causing that. If the location you're delivering to or going into is a place where cellular should be in place but isn't, then that's something that we can address very effectively, because one of the things that Eris distinguishes ourselves on is the ability to provide multiple carriers in the same location. So if you're dealing with a transmission of a device that has a key requirement to send the information from a particular region where a single carrier might not have coverage, we can find alternative carriers. Generally speaking, in most cellular zones, you will have at least one carrier, usually two, that's going to provide you some good service, but at least one. And the point is, if you're not on that carrier, you're not going to get good service, whereas we can select that carrier for you more effectively. So that's what we do. We worry about that, and we provide better service. Now, at some point, you're going to end up in a very rural area where you don't have any coverage whatsoever. That's very rare. 99+% of the population and location of typical fleet management applications, fleet management devices, is going to be in areas where you will have cellular coverage. It is the rare example where you're up in the wilds of Canada in an oil area, or perhaps delivering to a remote location, or having your fleet working in a remote location where you don't have cellular coverage. And clearly, if that need for transmission from that point is paramount, then you'll put together a hybrid application of some sort using satellites.
Okay. One more for you, Z. What are the things that I should look for in a telematics system? I need a system that I can keep in my trucks for at least 10 years.
I think both John and I probably have opinions, hopefully similar opinions about that. So let me address that from the perspective of what's going to be necessary for going for 10 years. If you have a device you want to install right now and you want to have it work for the next 10 years, then you probably should be considering 4G LTE for sure. That is the technology that you're going to need to use 10+ years from now. On the other hand, if you can sustain a change-out process, or the cost of 4G LTE is an issue, then I'd certainly pick a 2G CDMA device today. And that kind of a technology solution is a choice that many people are going through right now. It is a tough transition arena at this point, because there is a transition happening in technology, and you need to worry about that. One of the things that I've always told people is try and make the technology change something you can adapt with. So for example, if you have a hardwired device inside your vehicle, can the radio technology portion of it be swapped out? Can the radio module, if you're building your own device, can the radio module be put onto a pluggable sled? So if you need to swap that out, you can do so at lower cost than having to rip out the entire unit from the vehicle in some way. It adds initial cost right now because you have to deal with a plug-in radio device or the complexities associated with managing multiple types of devices. But in the long run, that's going to help you. Another important point I would make is that the firmware of the device, the application firmware that you have in your device, not the radio module, but in your device, is something that you ought to think about being able to update over the air. So if there is a transition from one type of radio device to a different type of radio device that perhaps has a different AT command set or perhaps operates differently and you need to make firmware changes, that you can do these firmware changes over the air later on to compensate for the differences. That's the kind of concerns that I would worry about for any application, let alone a fleet application that has to last more than 10 years.
Okay. Here's another one. John, maybe you want to tackle this. Considering cost of implementation and ongoing, how many devices would you suggest are the minimum for using Eris for our M2M data?
Well, one of the nice things about Aeris is that our pricing is very transparent. We make it real easy for customers to implement our portal, use our services. We don't have a lot of setup fees, startup fees associated with VPNs, static IPs, setup fees, and things like that. So we make it real easy for customers to onboard new solutions with Aeris and grow.
Do you have anything to add, Z? Or
no, I think that's a good summary. By the way, John, did you have a comment on the previous response I gave to longevity of the devices out there? I forgot to hand that off to you for a moment. If you had
the only thing I would mention, Z, is that we have a lot of consumer like telematics customers that are using OBD2 devices, and in order for them to accelerate their time to market and gain market share, a lot of them are continuing to deploy 2G devices. They were deploying 2G GPRS devices. A lot of them now are looking at 2G CDMA devices because those OBD2 type devices can be installed in the field relatively easy by a consumer. That's the only thing that I would add. So a lot of them are adopting 2G CDMA.
That's a good point.
All right. Well, that brings us to the end of the webinar. As I said earlier, we will send you an email with a copy of the slides and a link to the recording of the event. So that's it. If you have any questions, please email us at info@aeris.net. Thank you for attending.